Now we are going to discuss about the laser. The principle of laser is light amplification by stimulated emission of radiation. Laser is a device which emits a powerful monochromatic collimated beam of light, and then the emitted light waves from laser source are coherent in nature. Here shows the history of laser, invented in 1958 by Charles Towns and Arthur of Bell Laboratories. It is based on Einstein idea of the particle wave duality of light. Originally called Maser, or M stands for microwave. It is an artificial light source which exhibits so many superior features than the conventional light source. Metallurgy, biology, medicine, and then computer. And this is what is laser. A device produces a coherent beam of optical radiation by stimulating electronic, ionic, or molecular transition to higher energy level. And next one is the property of laser. The property of laser, or the first one is monochromatic, and second one is directional, and third one is coherent. These are three property of laser light, or what can make it more hazardous than ordinary light. Laser light can deposit a lot of energy within a small area. And first one, we are going to discuss about the monochromatic. Here, ordinary light spreads over a wavelength range of order of 100 nanometer, but a laser beam has a very little wavelength spreading of the order of 1 nanometer. Thus, laser beam is highly monochromatic. It emits only one colors of light. And second one is the directional. An ordinary light source emits the light in all directions, but a laser source emits light in only one direction. Basically, the divergence of a laser beam is very small, so laser light has high directionality. And third one is the coherent. That coherent is the light emitted from a laser source consists of wave trains. These wave trains have same frequency, phase and direction. So they are coherent. And in laser, um, laser beam is a high intensity beam. The laser source emit light as a narrow beam, and it is a energy is concentrated in a small region. This concentration of energy gives a high intensity to the laser light. And next one is the monochromatic. In monochromatic, laser beam has very little wavelength spreading of the order of 1 nanometer. The image shows the range, that is the comparison of wavelength of red and blue light. Um, and next one, this is the directionality. In ordinary light rate, it spread the light rays in all directions, and in laser, it is in highly directional beam can emit from the source. And this shows the incoherent light waves and coherent light waves, and this is the same. Basically we are using a normal lamp, first image, and second one is a laser lamp. In normal light we many wavelength and multidirectional and incoherent beam will occur, but in laser beam it is a monochromatic, directional and coherent beam will occur. And this is the basic concept for a laser. The basic concept of the laser, the first one is a absorption, and second one spontaneous emission, and third one stimulated emission, and then finally population inversion. That in absorption, the atom in ground state with energy E1 absorb the incident photon of energy h nu and is excited to a higher energy state with the energy of E2. This process is known as stimulated or induced absorption. And second one is the spontaneous emission. The atoms in the excited state, that is an E2 state, the E2 is called as higher energy state, return to the ground state E1, that is a lower energy state. It emits the photon of energy h nu. In equation form, del E is equal to E2 minus E1 without the influence of any external agencies. The emission of light radiation, which is not triggered by any external influence, is called spontaneous emission. It is a random and also uncontrollable process. And third one is the stimulated emission. Einstein suggested that there must be another mechanism by which an atom in excited state can return to ground state. He found that there is an interaction between the atom in excited state and photon. During this interaction, the photon triggers the excited atom to make transition to the ground state E1. This transition produces a second photon. It is similar to triggering photon with respect to frequency, phase and propagation direction. This kind of forced emission of photon by the incident photon is called stimulated emission. It is also known as induced emission. It plays a key factor for the working of a laser. Thank you.